Welcome back, Year 13. This is the second recording for your IP feedback and MRI, and this one will focus on the coast section. So this was worth and will always be worth 40 marks of your overall total. So it's a big topic. As you know, it took us a long while to actually learn it in lessons. Some of this you did in lockdown. We've gone over it in lessons for your IPE. So in this topic, you will always get your 2 6-mark questions, and there will be resource questions generally. So you'll be given something to use to answer the question with. You'll get an 8-mark explain question and a 20-mark evaluate. So coastal landscapes and change. So this is all about coastal processes of erosion, transportation, deposition. But it's also about hard engineering and soft engineering strategies, formation of dunes, and it's also about sea level rise and coastal change, and so on. So the first question, question 3A, in this section of coasts is on screen for you now. And you were given figure 3A, which is on the right here. And this is obviously of a cliff that has been eroded. And you were asked to explain the contribution of marine erosional processes to develop this landscape. In other words, what processes that the sea are involved in have developed this picture. Now, let's just comment on the picture for a minute, because a lot of you did this question, I must say, pretty badly. And actually, this was the 2019 paper. The examiner's comments from that also said most students answered this question very badly. You have all of the knowledge to answer this question. So let me just go through a few things that I pick out when I see this image. Flat plane here, just before the cliff. We've then got a bit of a wave cut notch throughout. You can see the different bands in lithology or geology in this rock. So this rock at the bottommost part here is a different color and a different type of rock to what's just above it. And you can also see that this cliff face here is mainly white. You can see again the horizontal bands in it. So the rock structure itself you can see. And then at the top of the cliffs, you can also see it changes again to more soil type structure. And you can see evidence that there has been cliff fall or there has been rock slides happening on this cliff. So there is lots of information there already that I've just pointed out that none of you really wrote about. So that's really important. Always analyze the image you are given. Forget about the question. What does the image tell you first? Now on screen, there is a sample answer that was given 5 marks out of 6. Let's just have a quick discussion through it. So it mentions a wave cut platform straight away and a wave cut notch at the bottom, which you can see very clearly. It mentions that that's been caused by erosional processes in the ocean, hydraulic action. It mentions the cracks and joints in the rock. It also talks about this rock being limestone, so it's easier eroded because it's acidic. It also says weathering has had an impact at the top, as you can see here. It also talks about gravity causing the rocks and the soil to collapse. It talks about attrition and how attrition can hit rocks off the cliff itself, and that can continue to actually degrade the cliff itself too. And then it goes back to the figure and says, and remember, there's a wave cut notch at the bottom and there's a wave cut platform shown in figure 3A. So that's a pretty comprehensive, a good answer overall. Lots of processes in there, used the figure really well, but it did not get a full 6 marks. So why not? So, as you can see in green, this is what the answer did really well. So, good contribution of erosional processes, applies knowledge and understanding well, connects it all together, and makes relationships between the photograph and the question. So, what it could have done a bit better is as follows. It says, the examiner said here that the response correctly identified hydraulic action and corrosion. It also examined subaerial processes like weathering, but it could have examined the processes occurring on the top of the cliff where there is a distinct change in cliff profile. So I mentioned that earlier. Look at the top of this cliff. That is very different to the bottom half of the cliff. So the answer given by the candidate did not mention that there's a change in the processes up here. Cliff is very different. And that is what was missing from this answer. An extra sentence or two would have got it full 6 marks. So, your content to include, therefore. Use the photograph throughout. Look at the photograph at the start. Look at the lithology. Look at the geological structure, the cracks and the joints and the horizontal lines and the vertical lines in the rock. Think about weathering and mass movement and how they create erosion. Think about the marine processes of hydraulic action, abrasion, corrosion. Think about attrition as well and how the rocks are constantly bashing from the sea off the cliff and further eroding it. You should have easily noticed that there's a wave cut notch and a wave cut platform there. Very obvious. That's very GCSE. And at the top of the cliff, there is a change in lithology. There's more weathering taking place, cliff collapse and soil creep is taking place, as you can clearly see again from the photo. Okay, so that is question 3A. Again, as I said, this was answered pretty poorly, so you will need to improve on this. Question 3B was a similar question. Again, it wasn't answered brilliantly. So this was a 6 mark answer that you have in front of you. Again, you can stop this, take the time to read it, open the PowerPoint if it's not very clear, and read it in more detail if you want. Study figure 3B. Explain the contribution of coastal deposition to the development of this landscape. Let's again look at the figure without even thinking about the question. What do we see? This is a coastal plain. It's a sandy beach. It's relatively flat. Behind that, we have some marram grasses. We have what looks like sand dune formation. Although it's in a bit of a crater, that could be because of wind erosion. We'll have a think about that. As you can see, there's a very distinct line as you go further back here. There is more stabilized grasses. There's even some shrubbery / trees here. Further we go back, you can see the more dense the trees are. And even further back, we can say we're inland there, and the sand dunes have fully stabilized and the land is fully stabilized. Now, coastal deposition in this photo. The idea of deposition here is wind for sand dunes and obviously the force of the swash for the sand up the beach. So, let's look at the answer on screen. The answer on screen mentions coastal deposition occurs when material is eroded, then transported, and there's a loss of energy. The answer mentions attrition contributing to deposition as well. The answer says that the waves seem to be low energy here, so it's constructive waves. I would agree because it's relatively flat. The answer also talked about, therefore, deposition taking place. It talks about sand dune being developed in the foreground, which is here. Deposition from the constructive waves and the wind blowing into that sand dune. It also then mentions marram grasses and plant succession and how pioneer species over time are developing as you go into the background of the photo. And it also says that the layers of soil as you go back further, therefore, get better, more fertile, and they are humus. And all of that is caused because wind erosion and deposition, wind deposition and coastal deposition have deposited the sand dunes here to enable grasses to grow. So that is an overview of that answer that's given there. And it is a pretty perfect answer, to be honest. It answers it really well. It takes the idea of deposition and says, well, that's linked to creating the sand dunes. The sand dunes are needed to protect the coast. The sand dunes also have grass to grow. And further you go back from there, because of more and more deposition, the better the soil gets, the more grasses, trees, and shrubs you get. It's all because of that plant succession and sand dune succession. So the examiner said here that, as I've just said, it's a really good answer. It clearly applies its knowledge and understanding to the image given, and it links them directly together. The answer had a range of ideas. It also mentioned things like wave type, which it didn't need to, and plant succession and so forth, which really show that this candidate has a very clear idea of how this landscape has formed and how coastal deposition has caused it. So, content to include in a list for you to redo this answer. Use the photograph again throughout. Make sure you refer to it. That's where your answer is. Identify that it's a coastal plain, a sandy beach, and that sand dune formation is happening. Explain what causes the beach to form. So it's deposition from erosional processes, type of rock. So it might be a limestone that's broken down really, really easily into sand. Mention the wave type. That's important for deposition. Constructive waves deposit lots of material. And also, plant succession can be seen very clearly in the photo. And you can say that. You can see the pioneer species such as marram grass forming. And the further you go back, the more stabilized the grass species and shrubs and trees. But say what you can see. Okay, we're on to question 3C now. Now, question 3C is an 8-mark question that says explain why a range of approaches is needed to manage coastal landscape. And that is worth 8 marks. This answer on screen got 6 marks. Why do you need a range of different ways to manage a coast? Why can't you just manage all coasts in one way? So, let's just go through what this answer has in it. So, different shapes. It talks about different recession rates. It says that hard or soft engineering can help. It says hard engineering is more expensive. For example, groins, they stop longshore drift from happening and they reduce recession rates as well by keeping the sand in a particular area. Then it says soft engineering is more natural, like beach replenishment or managed retreat. This is effective where there's nature reserves or where the environment needs protecting. This is valuable for tourism, for example, based on a cost benefit analysis. And it says some sediment cells also might require multiple methods of these. It's not just one or the other. Sometimes you need a mixture of hard and soft engineering. So this answer did really well in terms of geographical knowledge. It has a broad understanding. It's fully developed. However, it did not get 8 marks because what it doesn't do is consider a range of ideas such as recession rates in further detail, or the environmental sensitivity of an area, or the land value of an area, being the reason why you might approach places differently. So, to get 8 marks in this answer, you need to show that, for example, land value is taken into consideration, environmental sensitivity and nature is taken into consideration, and actual recession rate, whether it's worth saving or not in some areas. So, on screen for you now, I've got a list of content to include again for you when you are redoing your answers. And there are 2 possible approaches to answer this question, and I've listed them here for you. One way you can answer this question um, is based on the type of management. So you could talk about how you could do nothing and what would happen, and why that's useful and why not. Or you could talk about holding the line, etc., and how that's useful and sometimes not. And then you could explain the different approaches that are used there. The other approach, which this answer did mostly, that you had on screen, was to talk about the different strategies and why they were needed. So, for example, why hard engineering is used and what it's useful for, and why soft engineering is used and what it's useful for. As I said, this answer you have on screen didn't very well go through land value, environmental sensitivity, and rates of recession. You would just broaden that out a bit by explaining what they are and how they inform the decisions or approaches used. So both approaches are fine. In truth, it's a mixture of both, really. Recession of coastline informs what management is needed. So the recession rates are important to tell us what exactly is needed to happen. Hard engineering advantages and disadvantages with examples are used, and this answer does that pretty well. Explain what the good and bad parts of using hard and soft engineering are. And this last bit is not needed, but some of you will want to do this because you know it and it's useful to you. You can use Holderness as an example of a place that has a mixture of hard and soft engineering and how that was needed there. And it wasn't just a one approach solution. And in some places on that coastline, obviously, there's also do nothing. So that's a good coastline to use as well. So that was question 3C. I hope you found that useful. please just go through this content to include list and make sure that you can tick it off as you go. And finally, question 3D, 20-mark question. Most of you did pretty well on this question, actually. Evaluate the view that coastal flood risks are increasing mainly because of rising sea levels. In other words, what do you think about the view that coastal floods are happening more and more often because we have higher sea levels? What arguments are there to agree with that view, and what arguments are there to disagree with that view? Now, as you can see, this candidate's answer in 2019 wrote a plan at the top. And you don't have to do that, but the examiner actually can look at that and say, well, okay, at the start, they can see that they've got some agreeing and disagreeing arguments. So it kind of informs the examiner of what the answer is going to look like. Please do use the 2 or 3 minutes you have to plan the answer. Don't just bolt into the answer, because you will not end up having a coherent answer that's well paragraphed and structured. Now, let me just go through quickly what this answer mainly talks about. That mainly talks about the fact that rising sea levels are a threat to mainly low-lying areas, places like Tuvalu, Kiribati, etc. It also talks about rising sea levels killing plants and vegetation along coastlines, causing salinization of soil, and therefore there are further problems with that in terms of flooding, for example, in Bangladesh. And then it generally talks about the fact that rising sea levels are a fact and that they will obviously lead to some sort of increasing flood risk. It also has disagreeing arguments throughout the answer, such as ground subsidence and the problems that causes, like in the southeast of England. It also talks about deforestation and how deforestation linked to the vegetation by humans is a big problem, and that causes more flooding, and that's not to do with rising sea levels. It finally also talks about the risk itself of urbanization along a coast. So, building urban areas along a coast on lowland areas is going to increase the threat of flooding, etc. So, this answer then, really good answer. It tackles most of the issues really well, applies the knowledge really well. It's rational. There's balanced arguments between agree and disagree. It tackles both rising sea level as well as other factors such as vegetation removal. There's a very strong conclusion here where the candidate evaluates the information and provides to a justified answer. So in the conclusion here, it says overall the increasing risk of flood of coastal flooding is caused by a range of factors, but it's easier to argue that human factors have a greater influence. So this candidate has decided that actually ground subsidence, deforestation by us, and urbanization by us, and us removing plants, etc., actually that's a big, easy cause of flooding along coastlines rather than rising sea levels. Important to say, the candidate is not saying that rising sea levels are not increasing flood risk. They are, but she's saying, or he's saying, that increasing flood risk is also caused by humans. Remember to peel paragraph and structure the answer with your introduction, which is the key terms in your overall view. About 4 paragraphs. Ensure you set out your arguments and your knowledge, your counter arguments, your howevers, and link that all to flooding and rising sea levels. And then your conclusion is answering the central question and summing up your best argument, everything you have said. On the next slide, I'm not going to go through this in absolute full detail, but this is a structure for you to follow to rewrite this question if you didn't do so well on it and answer it brilliantly. So this is something that I've written out for you. You can use and you can write your own answer in detail following this guidance. As you can see, you've got your introduction, your 4 paragraphs, and your conclusion. And that is all set out for you so that you can build your argument. And then when you have written this, compare this to what you wrote in your exam and see what the difference is. And then you will see why you got, let's say, 10 marks out of 20 or 12 marks out of 20. Please make sure you use your notes as well. This is not a section where I'm going to reteach you everything. It's all in your notes. Go and use them. So that is all of the coastal feedback for your IPE. Please make sure you, particularly with the 20-mark question, if you need to redo it, if you've been told to redo it, please make sure you go back to that previous slide and use that as a structure for redoing the answer. Use the candidate sample answer as 18 out of 20 marks to see what they did. You've got all of this information. You might not remember it all, but you've got all of your notes. The revision books and the textbooks are on the system. Use them to build your answer. The more you practice them, the easier it will become on the road to your A level in a couple of months' time. The next video will be for the water section of your IPE.